Okay, so as everybody knows, we're the Center for Clinical Trials and Evidence Synthesis, and today's talk is going to be upon evidence synthesis from people from Computable Publishing, LLC. The lead person is going to be Brian Alper, who is actually trained in both family medicine and clinical informatics. He was on the faculty at the University of Missouri, Columbia. But since 1995, he's been involved in a variety of projects related to basically evidence-based medicine, first with systematic literature surveillance, then with evaluating guidelines and integrating guidelines, and in particular, integrating guidelines where there are inconsistencies across various recommendations. He's worked on clinical trials and on reporting of clinical trials. He's worked on a variety of activities. And he's now has a project or a company, which is Computable Publishing, LLC. And he has a project to extend fast healthcare interoperability resources for evidence-based medicine. And he has a COVID-19 knowledge accelerator. He's joined by Joanne Dehnbostel, who is has a master's in public health and is focused on immunology, microbiology, and infectious diseases, and Khalid Shahin, who is a computer programmer who works with him on this. I'm going to turn over the podium to Brian to get started, and we're delighted that you're here to speak to us.
Okay.
Oh, sorry, one other comment. When he finishes, we will have questions. Anybody who wants to list their question in the chat room is welcome to do so. Otherwise, we'll go through our usual free-for-all upon the end of the talk. Okay, now take it away.
All right, thank you. And just starting with some disclosures. As you heard, I own Computable Publishing, and Joanne and Khalid are employees of Computable Publishing. As a company, we augment digital publishing with machine interpretable forms, offering publishers the ability to extend their digital work into computable formats, and users of any type support in how to use the computable expression of this knowledge. Most of this talk is not specifically about Computable Publishing, but about COVID Knowledge Accelerator and EBM on Fire, which are completely open, transparent projects, no commercial activity, no cost, and you're more than welcome to be involved in any of the aspects of the things that we'll be talking about. So there are many groups now approaching the whole concept of how do we make things better, learning health systems, many different names for this overall effort. The AHRQ has a project called Evidence-Based Care Transformation Support, or ACTS, and a vision of this digital knowledge platform that goes through the whole cycle. And one of the things we are doing across the COVID Knowledge Accelerator is looking at this model and saying, what can we do at the infrastructure layers to help support making this overall process and system a reality? But where are we today, the healthcare knowledge ecosystem today? We have more data than we've ever had before. And of course, we want to use that in so many different ways. And whether it's observational or interventional, we want to analyze this data and turn it into evidence. But getting from that data to the evidence is not easy. It doesn't just happen at the push of a button. You have to sift through the data one small piece at a time and somehow get it to fit where you're trying to go. Then you do all the work to produce the evidence results. And we want to use that to inform making something happen, or guidance. We want to inform the guidance. And again, it's difficult to get the evidence in a form that's easily used for guidance. And we do all this so that we can make things happen. And same problem, every step along the way here, the data needs to be deconstructed and reconstructed to understand as evidence. What we produce from that needs to be deconstructed and reconstructed to make guidance. deconstruct and reconstruct to make decisions and take action. And it's not only not so well coordinated, if we try to make one thing happen to drive the next, we just end up spinning our wheels. And that's what it feels like in the healthcare knowledge ecosystem today. What we really want, the desired system, is each component smoothly works with the next, and it becomes a well-oiled machine, and everything just moves smoothly across all of this. How do we get there? Another way of looking at the evidence ecosystem, and this is from the Magic Foundation in Norway, is again, all these parts have to come together for this cycle of producing evidence, synthesizing it, producing guidance, implementing it, and so on. What are we creating at each of these steps? For this focus with this audience, I'll really focus on producing the research studies, producing the systematic reviews, and then producing the guidelines, decision aids, and clinical decision support. How do we make it better, faster, easier, more accurate to make all of this happen? The answer is in the data. If we can make the data flow more easily from research studies to systematic reviews, flow more easily from systematic reviews to guidelines, more easily from guidelines to computerized clinical decision support, that would help everyone across this whole area. How do we do that? Apply standards. If we did it all the same way, it'll be easier to transfer the knowledge at each step. Applying standards can mean many things. You may think of, guidelines as standards, policies, and procedures, and at some point, specific content and contextualization in specific people is part of that. But at a technical layer, we need to have a common format for how the data is exchanged, or the schema, common terminologies for how we describe things, and then common tooling, interfaces for how we work with this. There is an organization named Health Level 7 International. It is a standards development organization and has been focused on healthcare for decades, is very, very widely represented globally from all sectors. And one of the standards that they have developed is called FHIR, Fast Healthcare Interoperability Resources. What is exciting about FHIR is it is overcoming the interoperability challenges of communicating data with electronic health records like we've never seen before. This has been an insurmountable problem for decades, frustration to many, and it is now a reality and getting even closer. In the next 2 years, we expect everyone in the US will have the ability to get all of their electronic health data on demand at the push of a button in FHIR format. And there's regulations that basically say that that needs to happen. So FHIR is a standard that has solved this interoperability challenge for healthcare data. How do we apply standards to the evidence domain, the things we're very interested in here with clinical trials and systematic reviews and guidelines? Well, what if we could apply FHIR to the evidence domain? And I was charged in 2017 by various groups in the evidence-based medicine community to help take lead in steps towards reaching interoperability. In 2018, I learned enough about FHIR to see how it solves the problem for health data. And I got HL7 to approve a project to extend FHIR to evidence-based medicine knowledge assets. Specifically, let's create FHIR resources as standards for communicating research findings and guidance. In 2020, when COVID hit, there's so many groups coming together to collaborate like never before to advance knowledge for COVID, and they wanted to use these EBM on FHIR resources. So we started the COVID Knowledge Accelerator, which is an open virtual organization that now has 10 active working groups meeting weekly. And as I'll show you through the rest of this presentation, there's many developments with this and many ways we would be happy to work with you across these areas. So the COVID Knowledge Accelerator has activities in all 4 components of these standards. If we start with the schema, common formats for how data is expressed, we have many FHIR resources, and each of these is the way to share that type of information in a standard format. For terminology, we have many code systems. There's 35 different code systems we need to work with to express all this evidence. And this handful we'll talk about in a moment why we're focusing on these 4 or 5 systems right now. For tooling, there's many tools. Clinical Trial Results Reporter will be one to especially talk about today. And then there are many groups like the ACTS group that I showed you a slide from in the beginning, COVID-END, which includes Cochrane and many others globally to focus on knowledge for COVID, and then a systematic meta review project group within COCA. And Joanne will introduce you to one of our projects later in this session. So for the schema focus, all of these FHIR resources, what does that mean? And I'll try to rapidly show you what this looks like at a technical level for standardizing the communication of evidence. So this is on the left, the highest level elements within an evidence resource. When you convey a single piece of evidence, you can use these elements to precisely describe each of these things. And I blew up the portion in the red box here. And you'll see some of them with a plus have elements within them. So for a variable definition, you do that by describing the variable, by coding what is the role of the variable, the population, the exposure, the measured variable. You can reference other resources. What is the observed version of that variable? What is the intended version of that variable? You can code the type of synthesis or type of study. Statistic we'll get into in a bit more. And certainty has many sub-elements to be explicit in what aspect of certainty you are rating, who is rating it, what is the rating. Each of the things that can be identified to be transmitted gets formats like this. So in addition to evidence, the variables have resources to describe the definition of that concept. The evidence and evidence variables can be compiled in evidence reports. When we're describing a group of people, we'll use a group resource to describe the group, like a population. And then even citation management, we've discovered with COVID is a big challenge where there's many citations that are not in Medline and a need to deduplicate and coordinate across citation repositories. So we created the citation resource to be able to have interchange between Medline and all other forms of citations. These are the primary resources for communicating evidence in a standard computable form. And then some of these elements require special data types to handle. So an example is the statistic element. We'll use the statistic data type, which has its own set of elements to express. So here's an example of what it looks like in computable code to express a single statistic, in this case, an age-adjusted rate ratio, and you'll see the coding of the statistic type itself. The quantity in this case is 1.15. You see the number of events, the sample size. Further down, you'll get what we call an attribute estimate, which encompasses all of the data in granular detail to fully code the confidence interval in computable form. Another area that we have to work on to have a standard computable expression is the terminology. I showed you there was a code for the type of statistic in that focus form. Well, there is a statistic type code system in development. At the time this slide was taken, there were 89 concepts that we were making unique codes for. And you can see in this example, incidence rate ratio is one of these concepts. We discovered when producing the standard for expression that there were many concepts that do not have fit for purpose code systems. There's SNOMED and ICD for conditions. There's RX norm for medications. There's LOINC codes, which can be used for laboratory measures and many outcomes. But there is not great code systems for expressing statistics. So we have developed a code system development protocol, and we're applying it right now to 4 code systems: statistic type, statistic model, study design, and risk of bias. And the 13 steps, we're being very comprehensive. As you'll see, step 1 is to assemble an expert working group. You are welcome to join if you would like to help with any of these code system developments. And at the moment, we have 61 people from 27 countries helping with the development of one of these code systems. Step 2, we ask, are there commonly used tools or systems where you would need these codes? And 24 such tools and systems have been identified. Half of them are risk of bias assessment tools. Step 3 is to draft the non-redundant concepts needed to support all those tools. And at the moment, we have 444 terms to make codes for across these code systems. Step 4, we've identified 27 eligible ontologies where people have already mapped out definitions for these concepts. And we're in the middle of step 5 now, about a third of the way through, mapping each of these 444 concepts to anything already mapped out in ontologies. Steps 6 through 9 will be a process for each of these concepts to identify the optimal term, alternative terms and definitions, and then have wide-scale consensus from the expert working groups for the exact code systems for these 4 code systems. And then the later steps will be publishing the code systems and setting up ways to evaluate their implementation and have continuous updating for these code systems. So of the 4 code systems, this is just a breakdown that shows you how many tools or systems were mapped to meet the needs of for each code system and how many terms. And then these links, and you'll have access to the slides, could show you the current snapshot of the different code systems as we're developing them. So the areas that may be of greatest interest will be the tooling and then the specific projects for this group. But if you are interested in the technical layers of these things, you're more than welcome to get involved at the schema and terminology layers. 2 of the work groups within COCA are tool development work groups. The content citation and classification tools development work group has a goal of creating the infrastructure, standards, and tools to support interoperable, reusable efforts for citation repositories. And you'll see a glimpse of that with Pico Portal when Joanne shows you how we're applying that to the COVID, steroids for COVID systematic meta review. The evidence evaluation and reporting tools development work group is working with helping different tool developers share their work transmitting computable evidence. And SRDR, Systematic Review Data Repository, has been able to express their outcomes in FHIR format, and we can show it in the outcome definition viewer. And then what we'll have a chance to show you in greater detail, I'm about to turn this over to Khalid, is to show you the clinical trial results reporter, which was initially set up for something like enter the data for clinicaltrials.gov and show that we can make it easier to enter the data, and you can get a FHIR-based format for reuse of the data afterwards. So this version of Clinical Trial Results Reporter is set up to support dichotomous and continuous baseline and outcome measures and convert all of that to the FHIR format. So I can click through if you'd like, Khalid, and you can take it from here.
All right, sure. So we developed a piece of software that's actually now available publicly to make it easier to enter in clinical trial results. And we believe it's better than what's currently used within clinicaltrials.gov. All right, let's go to the next slide. So after getting your project started, the first thing that you have to fill out are the details of the study, the study title and the identifier. And by default, we selected randomized clinical trial. But if you clear that, you can also pick other options, but we figured RCTs would be the most common. And we also put in a field for the number of participants. We added that field kind of late, but we found it would be helpful to capture how many people, how many participants were in that study. And right now we capture population information as a series of strings. So it doesn't link to any code system or anything like that just yet, but that's a feature we're looking at adding. So you can fill out the population short name, so it can be referred to later in the file resources, and also the population description. We also have inclusion, some basic inclusion criteria, which would be ages that are eligible, and the units, whether or not it's months or years that you're talking about. So we can say, oh, these participants ages 18 to 99 years old, and also the sexes that are eligible. So male or female at this time, and or all. That's you have the option to pick all sexes, and we also have accepts healthy volunteers, and that's just a simple yes or no. We also have intervention or comparator, but we're going to be adding additional trial arms. So it would be exposure 1, exposure 2, or exposure 3, etc. But right now it's just hard coded as intervention and comparator. So next slide, and we can see how that looks like when it's filled out. So right now, intervention and comparator are just a couple strings. So it's just remdesivir and 200 milligrams of remdesivir, et cetera. But we are thinking about adding additional features. Well, we want to add additional features, which are we could probably pick a RX norm code from a list, or you can be able to put in an RX norm code. So it would be able to be computer understandable of what those intervention and comparator are. All right, next slide. All right, so after filling out that basic information, we can get to the baseline measures. Here, it's going to be in a similar format to what a person, somewhat similar format to what people are familiar with when a clinical trials table is completed. So it's easy to look at and also entered in. You would fill out the base. The first thing you'd probably fill out is the baseline measure name, and whether or not it's dichotomous or continuous. And you could also fill in the description as well. And then you would fill in the subjects and the subjects with that characteristic for that baseline measure, and the total number of subjects for that intervention. So yeah, as you can see, there is these yellow boxes, which just simply indicates that something can be calculated, but it's currently not. So if you go to the next slide, we can see how it looks like when it's filled out. So the baseline measure here is the age, and we selected continuous for that baseline measure. And we said we're measuring a mean and a standard deviation with a unit measure of years. So here we're on the right in the placebo column, we see that we have 521 subjects that are measured with a average mean of 59.2 years old and a standard deviation of 15.4. And for remdesivir, we have 541 with a mean of 58.6 and a standard deviation of 14.6. And in the right column is the total with 162 being 521 plus 541, and a mean for that group of 58.9 and a standard deviation of 15. And in the next row, we have age between 18 and 65 years old, and this is a dichotomous measure. We have 324 of the 521 subjects are between those ages, which is 62.2%, which are all automatically calculated for the green cells. And for remdesivir, we have 354 of 541, which is 65.4%. And in the right column, all of that is calculated from those two input boxes in those
so
two columns.
This is basically set up to allow you to enter data the minimum number of times. You can specify things about the way the measure is reported, like mean, standard deviation, unit of measure once, and reuse across the entire row. When you set things up here and you add new rows, it will remember some of those features to let you reuse those things. And you can set the number of subjects at the top and set as default if you want to use it for the same number for subjects measured all the way across. And then everything in green is calculated. You don't have to enter that data from the data that you put in. So that's part of our goal, is trying to make this as minimal effort as possible for the person entering the data.
All right, and then if you navigate to the next page, we have outcome measures. And here, it's going to be very similar to the baseline measures, but we have a new, have these couple new, this new section, which is time from start of study. So it would be outcome measures measured at, like 7 days after the start of the study or 14 days after the start of the study. And then you can say, yeah, so, days would be the most common one. I believe that would be selected, but you can also be years after the start of the study as well. Yep, and this is what it looks like when it's filled out. So here we have creatinine change baseline to at, to day 29, which would be 28 days after the start of the study. And we have made this a continuous measure, a mean and a standard deviation with a unit measure of milligrams per deciliter. And yeah, so we filled out just the same. It doesn't look all too different, but the big change is that this is a comparative rather than a total column. So you get a mean difference of 1.9 milligrams per deciliter. And this is for remdesivir versus placebo, with remdesivir being first in that comparator. Yeah. And when you do a dichotomous measure, a dichotomous outcome, it will display a risk difference rather than a average difference. So for placebo, we have 1.3% with a confidence interval between 0.4 and 2.3% for placebo, and for remdesivir we have 0.6% with a confidence interval of 0.0% to 1.2%, with a risk difference of negative 0.8% with that confidence interval, and everything in green again is still calculated from the input data. And then when you go to the next page, this is just a very simple, quickly made study summary automatically generated from what you entered in. It summarizes everything with the study information, population, exposures, and baseline measures and outcome measures in this format. And you can copy this and to Word, for example, and print it out if you would like. Next slide.
You can also save it to a text file or convert to Fire and save it in Fire format. It'll do all the transformations to turn this into Fire resources. So that's an example of the tooling that we're developing to have that interface between the human experience and all of this computable form to make all of this easier. And even if we have all the tooling and all the schema and all the terminology, it still needs to be applied each and every time to a specific context, specific content, specific people. So there's many groups that can work with this in a number of different ways. And we'd love to have your group be one of the groups working with it in any number of ways. And within the COCA effort itself, we have a systematic meta review project group that has determined right now steroid therapy for COVID-19 is a top concept for demonstration and development of how to do a systematic meta review or systematic review of systematic reviews for this area. So with that, I'd like to turn it over to Joanne, who's taking a number of leadership roles in making this systematic meta review come to life.
And as Brian said, this is a systematic review of systematic reviews, which is a little unusual. And our goals for that are to determine the consistency of findings and judgments across systematic reviews of steroid treatments for COVID-19. We need to determine the most current, accurate findings and document those findings in computable resources for efficient updating and dissemination. We've written a comprehensive protocol for this endeavor, and soon it will be published. And we've used a number of different database sources that we'll include in our systematic review. We have a complicated search strategy that we hope will give us articles specifically on patients with COVID-19 that are treated with different steroids, which include systematic reviews of at least one RCT and have a comparator that does not include steroids, so we can make a good comparison. And you can see the developments to come here on the right-hand side. I can tell you that a preliminary set of citations has already been compiled and deduplicated from 9 different database sources. We're collaborating with Pico Portal website with this. And here you can see we have a Prisma diagram created in Pico Portal. And we have created a mega file by adding 9 RAS files from 9 different database searches. And those 9 different database searches altogether included 1,254 total records. And then Pico Portal has a system that will allow us to deduplicate. And so even though many of these databases contain the same citations, we were able to exclude 598 of those as duplicates through the mechanics of Pico Portal without doing that by hand. And so we are now looking at those 656 articles that remain, and we're doing some preliminary screening of those articles to be sure that we have a good search strategy and we don't want to go back and narrow it a little bit more. You can see that Pico Portal is created just for this job. It's cut off a little bit on this slide, but you can see that there is a button to either accept or reject each of these articles as you look at the abstract. And so you've even got a maybe button. And then you can select a reason to exclude. So you can select a population reason or a study type reason, or even put in your own unique reason for exclusion. And you can see also that as you're looking at the abstracts in Pico Portal, that they are color coded, and this is AI enabled highlighting. So you can see that the population, for example, is in yellow, and the intervention is in purple. And so you can pick out the individual points as you're looking through these abstracts very easily. It's a very nice tool to use. If you've ever had to screen through these things without this tool, you know that this is a great improvement. So here you can see all the list of the elements we hope to capture for the systematic meta review. And so all this information will be captured eventually in FIRE format. Population specification, intervention and comparator specs, outcome specifications, statistic type, statistic quantity and value, sample size, statistic attributes, certainty rating, by systematic review, and risk of bias assessments of the systematic reviews. And in the future, we're going to be able to create data entry support for this also. So you just saw the clinical trial results reporter, and we will soon have a systematic review results reporter. And that will create FIRE resources for group, evidence variable, evidence, and evidence report, and also create a system to notify us when changes occur so that we can create living reviews. And now Dr. Alper will tell you about some exciting events that are coming up.
Okay, one of the things that HL7 does is 3 times per year, they have a connect-a-thon. Typically, a connect-a-thon is hundreds of engineers and implementers in a room together for a weekend. And basically you just have that availability without having to wait and schedule. And you can get a lot of advancement on the technical engineering in making systems work and communicate with each other. And that has been very successful for many years. So that this connect-a-thon coming up is the 26th HL7 Fire Connect-a-thon. With COVID, things obviously changed, and they've shifted to virtual connect-a-thons that over a couple of days, happen during weekdays now instead of over the weekend. And the increase in connect-a-thons has actually skyrocketed with going virtual. It's easier for many to participate, and the costs have gone down as well in that virtual. So if you are interested in the technical layer, mid-January in this connect-a-thon, you can learn a lot more about all of these resources, use tools to create the resources, get help transforming your data into these resources, and be happy to follow up with you if you have specific interest in that. Again, the COCA has activities in all 4 components. If you're interested in the schema layer, you can share changes to shape the FHIR resources at the core to enhance this communication demand. For terminology, you can join an expert working group to help with, these are the active code systems we're developing now. For the tooling, you can use the clinical trial results reporter today. You can participate as a user and just give feedback to improve the tool. You could also participate as a researcher, and we've started drafting the feasibility and usability study to work with a protocol for that. And for the specific content and people, there's many things, and you've just heard about the steroid therapy for COVID systematic review. Getting involved in that could be getting involved in helping make it happen and be part of the team producing this systematic meta review. But one of the things we hope to do, as Joanne noted, we'll make these available as FHIR resources and set up systems to be notified when there's a change. That can not only be useful for those producing the systematic meta review, but if you have a reason to know about any of the results as it is coming out, maybe to update your review, to update your guidance, to update your clinical decision support, we can learn how to make systems. How do we send a signal when something changes? And maybe you're just interested in the summary of findings of this review and when it changes. So that could be another interest for you. So COVID Knowledge Accelerator is an open project. This is our weekly schedule when each of the different working groups meets, Eastern time zone, regular times through the week. And any of these meetings you can join with a Microsoft Teams meeting. And we made it easy by making it the same exact link for every one of these meetings. tinyurl.com/COKA2020 if you need an easy way to remember, but you should have access to these slides. And we'll also post them on an open space in the, in the COCA space as well. And there's my email address if you have any questions and you'd like for follow-up. So with that, I believe we've allowed about 15 minutes left for any questions or discussion.
Hi, this is Janet Holbrook. I'm a member of the center, and thank you for the interesting presentation. I had a particular interest in the clinical trials slides because I've struggled with the clinicaltrials.gov often. And I have to say, having the subject number that you could change for variables, great. That is very frustrating that they don't seem to understand missing data. But I did notice that, one of the difficulties we've had is like if you have a crossover design or an adaptive design or a factorial design, they are not very well incorporated into clinicaltrials.gov. And I was wondering if you are planning to kind of expand those designs some.
Yes, so the simple answer is yes. The more detailed and complex answer is yes, but there are many variations we need to adapt for. The crossover design, as opposed to the parallel cohort design, is one of those variations. But the handling of categorical variables, in addition to dichotomous and continuous, variables is another variation. The handling of other statistic types. It automatically calculated absolute risk reduction in some of the examples, but maybe you want to calculate relative risk or an adjusted odds ratio, and then you have to handle the adjusted analysis. How do you handle, what are you adjusting for? And we, of course, cannot do the automatic calculation, but how do you express an adjusted analysis? How do you express if you're doing a systematic review and it's a meta-analysis with random effects as opposed to fixed effects analysis? And even beyond that, you know, what are you using for tau estimation? So when you break into the real zoomed in details, there are many, many elements for the study design, crossover being one design concept. There are many elements for the statistic type, and a relative risk statistic type will have different needs than a mean statistic type. There are many elements for statistic model when you get into the nuances which have effects on the statistic type. And you get beyond the reporting of the results itself, and then if you're evaluating it, there are many elements for risk of bias or certainty assessments. So for each of these concepts, we have to get very precise in the terminology, how it will be handled. And then with that, what are the user interface changes needed to support expressing those concepts? So we may start initially by allowing anything can be expressed with text. And if you want to say in this space, put in a text note that says it's a crossover study. And we can do that, and then later follow up with more coded, detailed concepts. So even in the examples, and I'll jump back to show you this concept, if we look at this statistic, we already have incidence rate ratio as a fully coded concept with a coding system. The quantity is coded, the number of events, the sample size, the confidence interval. But at the time that this example was created, we did not have the structure in the system and the codes to handle a computable expression of the concept age-adjusted rate ratio. So you see the age-adjusted concept has text. The authors report estimating it, this way, and text later to say that it is age-adjusted. If we show you the current form of the schema, we actually now have what's called a model characteristic element in the statistic element, and it covers all the detail you need to be able to fully code the concept of being age-adjusted. So each of these things can be done, and we will end up doing this. This is a foundational system to scale for the full spectrum of communicating evidence. One of the things we will need to do is determine the priority. We just can't do everything at once. And those using the system, we will set up a way to basically vote or express priority over specific feature development to help guide us. Is crossover what we should get to next? Is observational study next? Is risk of bias coding next? What is the next most important feature to develop as we enhance and build upon this system?
Thank you.
Brian, this is Paul Nagy. I wanted to thank you for the wonderful presentation. I'm an informatics faculty member here in the School of Medicine, and I was even chatting with Khalid. I teach a course on FHIR. I've been supporting a lot of the COVID clinical research here at Hopkins, and when we started looking at mapping our proprietary EPIC data to a data standard, we didn't feel FHIR was quite ready to support the clinical research needs of our faculty. So we ended up moving to OMA, which is a common data model, and the Odyssey community has built out a whole slew of different tooling to define cohorts, to define comparator cohorts, to define outcome cohorts. And they've done this all in JSON formats. They've even done data characterization in JSON. And so it seems like when you get JSON, you're really a half a step away from FHIR. You're already in the common syntax. And so I'm wondering, have you been, it seems like there right now is a sliver of overlap from what you're doing and the Odyssey community. Have you been working with those groups at all?
Not directly, but there's overlaps with other groups that we're working with. So some of that comes up. I've seen it mentioned in some of our code system development, ontology mapping efforts where that has come up. The EBM on Fire project was initially scoped for evidence and guidance, or evidence and recommendations. And then there's other groups. The CDC has an Adapting Clinical Guidelines for the Digital Age project that started working with FHIR-based groups on how to deal with the computable guidelines. And we ended up having a closely related group that we nicknamed CPG on Fire, that we're very coordinating with between EBM on Fire and CPG on Fire. So the CPG on Fire effort focuses on the recommendation layer, and EBM on Fire now focuses on the evidence layer. But one of the things we did across these groups and others is we said, we cannot do all of these things in isolation from each other. So when you see this set of resources, there's a reason we use the group resource instead of the evidence variable resource, when the variable role for evidence is the role of population. And the reason is so when we can describe a group of people or the population, we use the same resource that others are using for clinical decision support, for expression of guidelines, for describing the cohort in your research study. And you can use the group resource in FHIR, which is a different concept than the evidence variable resource that is completely definitional. The group resource can be an actual group, and an actual group can have members of the group, and the group can have a quantity, how many people are in the group. But the definition of the group, whether it is actual or conceptual, whether you're talking about the group of people the evidence is about, the group of people the evidence is derived from, the group of people the recommendation is for, the group of people you're trying to apply the decision support for in your medical record, and so on, having a common way of describing those cohorts would help across the whole ecosystem.
Yeah, so exactly. So defining cohorts as a group sounds wonderful, because I mean, we're publishing patients who are hospitalized with a positive SARS test based on a LOIN code, based upon whether they need to have ECMO or ventilators. And so we can define that, and that would be all defined by the characteristics within your group.
Right. So if you have JSON encoded group definitions, okay, not technically in FHIR, but JSON encoded and covering these things, we can likely do some relatively easy mapping to say, how would those be converted to FHIR group resource descriptions of the same concepts?
Yeah, that'd be really exciting.
So definitely email me, in follow, and we can find some time to, get some time to talk about that specifically and how we could do that mapping. Taylor just added my email address to the chat. That would help. Thank you.
So do we have other questions? So it sounds like you've left us all either completely clear on every issue or totally befuddled, probably the former. But if there are no other questions, then we can wrap this up. Brian and team, I want to say thank you very much for coming. It was a fascinating talk. I think we've enjoyed it, and it certainly has given us a lot to think about. And I applaud these efforts to standardize how we do this stuff, because otherwise it becomes uninterpretable, or at least non-comparable. And so I think this is certainly critical to the future ability to integrate what is an ever-increasing flow of information. So with that, I'll declare us over and thank you all.
Thank you.